it would be great because you have more controls over it. Otherwise, I'm happy to help you, and then just let me know when to change the slide, saying next. Like this is the only word I can remember now. If you have any better thing, let me know. A jingle, anything, please let. And of course, we have a diverse range of participants on from urban spaces as well as rural India. So please pardon us because I know you guys are very international people. But please pardon us if we get into a little Hindi in between, just to manage the crowd and the participants. Thank you so much for joining us and being this part of the program.
So we'll start in a few minutes, maybe 3 or 4 minutes, at 3 only.
Sir, Pinaki sir, the file name is not correct which we have to share. I think you have to refresh the download box. Pinaki,
Is it visible now?
sir, it is visible, but that is not the content we are sharing. The name of the file is different.
This is not.
This you have to find the other PPT that you were showing online.
Clear now, Manvi?
Yes,
We say I can share.
I can share. Yes, I can share.
Yeah, yeah. Is this the one? No.
No, this is not the one, sir.
So I will stop
I
sharing then.
yeah yeah
Manvi, you gonna share that?
yes, I will do that.
दूसरा लिंक हुआ क्यों हो रहा है
Namaskar and good afternoon. I welcome you all to the second session of today's international webinar on science and engineering for nature conservation on the occasion of the World Environment Day 2020. As the theme suggests, in this session, we would be articulating about sustainable development versus developmental engineering. I sincerely hope that your journey in this webinar would be thought-provoking and enjoyable. Just to break the moratorium, now I'll request the coordinator of the event, Mr. Pinaki, for augmenting the session and share a few housekeeping rules. I guess it is echoing. Can you please somebody switch off your mic?
Oh my.
That we would take you to the proceedings of the day. Pinaki, please.
Yeah. Dr. Smita, and welcome all of you.
Pinaki sir, you are not audible.
Hello, am I audible now?
Yes, yes.
Okay, sorry. Very good afternoon to all of you, and welcome on board this on the second session of this one-day international webinar on science and technology on nature conservation. I'm trying to put my video on so that you can see my nice face. But then, and thank you, Dr. Smita, my colleague and the lead coordinator for this webinar, to welcome you all. I'll just take a couple of minutes here to give you a broad background of the housekeeping rules, as well as introduce my senior colleague, Dr. Smita. As Dr. Smita is currently working as an assistant professor in the Department of Environmental Studies, JC Bose University of Science and Technology, YMCA, Faridabad. And she has obtained her master's in science and MTech, and she is also a PhD in environmental science and engineering. She has done her postdoctorate fellow from IIT Delhi, and she has been awarded the National Postdoctoral Fellowship by SERB for her research project in 2017 to 2019. And she has, to her credit, more than 50 research papers in national and international journals and 10 book chapters. And she has completed her research project under the supervision of Professor Vivek Kumar at the Center for Rural Development and Technology in Institute of Technology, Delhi. Thank you so much, Dr. Smita, for being in our team. Really an honor. I will just sum up the housekeeping rules now. Nothing much, but जो लोग यहाँ से आप लोगों से निवेदन है, जो लोग यहाँ से जुड़े हुए हैं गांव से कहीं से, आप अपना और कहीं आप अपना माइक म्यूट रखिए. People who have joined us from other corners of the country as well as from internationally would request, please keep your mic on mute mode so that we can listen to the speakers and their words of wisdom. So I would now again put back, and also if you have any questions, queries, kindly write into the chat box, not to everyone but to the host, so that we can take care of it. Again, a request not to open your mic unless and until you have been asked to, or because there may be some embarrassing moments which we all want to avoid. And let's hope that you will enjoy this session. So over to you, Dr. Smita.
Thank you, Pinaki, for the admittance. Now I would like to introduce our keynote speaker of the session, Professor Ranjana Agarwal. Professor Ranjana Agarwal is the Director, CSIR, National Institute of Science and Technology and Developmental Studies. Previously, Dr. Ranjana Agarwal has served as Professor of Chemistry at Kurukshetra University, Kurukshetra. She did 2 years postdoctoral research on erythromycin biosynthesis at Cambridge University, UK, before joining her alma mater in 1995 as lecturer. Subsequently, she worked in many well-known European labs, such as again at Cambridge University as Commonwealth Fellow, Trinity College Dublin, Ireland, and University of Trieste, Italy. She is actively collaborating with scientists from the USA, Spain, and Ireland. Her research contributions have been acknowledged in the form of awards, notably Dr. Basudev Banerjee Memorial Award, which was imparted to her in 2014, by Indian Chemical Society and Professor S.S. Katiyar Endowment Award by Indian Science Congress. As an accomplished academician, she has been nominated as member of National Monitoring Committee for Minorities Education by MHRD, New Delhi. She is visitors nominee for Delhi University and Central University Assam Silchar and chancellors for nominee for many Haryana state universities. To your incumbency, ma'am. I welcome you, ma'am.
मैम अपना माइक अनम्यूट कीजिए मैम.
Sure. Sorry. This coordination is very difficult sometimes.
Yes ma'am.
Yeah. So thank you very much, Samita, for the nice words of introduction. It's a matter of great pleasure for me to be here in this platform. At the outset, I would like to thank Professor Dinesh Kumar, Vice Chancellor, DC Post University of Science and Technology, Dr. Vivek Kumar, Professor, Center of Rural Development and Technology, IIT Delhi, and co-convener of Unnat Bharat Abhiyan, ASSOCHAM, and CP consultants who are partners. From Vibha side, Vigyan Bharati side, I would like to thank you very much for being partner of us and launching this webinar in such a big way. And I was very pleased when Samita shared with me that like 3,100 participants have registered and the response is so overwhelming. So thank you so very much, everybody. It's a matter of really great pleasure for me to be here. And I would also like to thank Dr. Pinaki Dasgupta, who is coordinating the whole program. And the speakers of today's session, Dr. Ajay Nagpure, Dr. Lucinda Elizabeth Doyle, Subhi Dhupar, and Shri Rishabh Khanna. So thank you very much for being part of this event. So coming to today's seminar, we all know it's like World Environment Day, and all over the world in more than 143 countries, it is being celebrated by millions of people. And it's good to know that we are caring about our environment by celebrating these. Am I audible?
Yes, ma'am. Yes, ma'am.
Okay.
Yes, sir, we
As you all know, it celebrates diversity, biodiversity. And if I say only biodiversity, I think biodiversity and climate or environment or nature, they are interconnected with each other in a very strong manner. So any loss to biodiversity also leads to damage to the environment, to the nature. The moment we, come to this planet Earth, we start taking from Mother Nature, whether this is water we drink, food we eat, air we breathe in, the climate we have, everything is given by the nature, but somehow, human-centric approach, which we have developed, and in some way, I think most of the cultures and most of the religion have also given us this myth that this whole planet Earth has been created by God only to serve the human mankind. We forget in that whole process that human being is only one of the species out of those million plants and animal kingdom. We are just one species, but somehow we are starting believing that these all resources are only for us, and we are not doing the optimum use of the resources. As Gandhiji said, there is enough for everybody's need, but not for everybody's greed. So this COVID-19, the present situation which has arisen due to the pandemic, I'm not sure whether this is God sent by the God sent for the human beings or not, but definitely it is for nature. We all have seen that during the lockdown period, when people were staying at home, no air travel was there, shops were closed, markets were closed, our industries were closed. I think many generations, younger generations, have never seen that kind of clean environment, clean air, blue sky, chirping of the birds, wild animals coming to the roads or the societies where the human beings are living. So a very positive outcome of COVID pandemic has occurred on the nature. And people are having very high hopes now, like, are we going to have this kind of environment all the time? I have my doubts, because and you know, as the pandemic effect will slow down, and we will be again, because the economy has gone down, so our manufacturing, our revival of the economy will be the major point, and at that point we will forget about the nature. So I'm not sure that nature will be bouncing back as we are believing. So I think this is the high time when we start thinking of opening up of the economy. And I think here, when we talk of sustainable development goals, at the moment we have put the sustainable development goals on the back seat, because at this moment our main focus is on COVID pandemic. We are forgetting how much water we are using now, how much chemicals we are putting into the water because of the sanitization and hygiene conditions, how much plastic we are generating in the environment. So all these sustainable development goals have taken backseat. And when we are opening up, it's very important that we uh, keep in focus our sustainable development goals. And the same time, developmental engineering has very big role, because we cannot have reversal of economy. We want economy to grow, so we must come up with the policies, with the strategies, so that we have clean environment, but at the same time we create livelihood for the people, particularly the people who have migrated to the villages. So what kind of things we can do for them? So I think these are some of the points I would like to raise, because the time given to me is 5 minutes. I don't want to overshoot. So I think there are very nice presentations after me. I have gone through this. All these resource persons are very learned resource persons. So they will be giving their inputs. And if we incorporate these inputs in our policy planning, so definitely we are going to not only win the pandemic effect, but also we will have a society which is more environmental friendly, which is more cautious of nature, and we will pass on a very healthy nature, good environment to our coming generations. With these words, again, I would like to thank the organizers, though Vigyan Bharati is also one of the organizers, but thank you very much for giving me the time. Thank you, Samita.
Thank you, ma'am, for such a gratifying talk. We shall try to include all the suggestions into the webinar proceedings that will be followed just after the event. Now, I would like to introduce our next speaker, who represents an international organization, World Resource Institute, Dr. Ajay Nagpure. Dr. Ajay Singh Nagpure is the head of air pollution in the Sustainable Cities program at World Resource Institute, India. He works on developing research strategies and conducting research in the area of air pollution and health risks. Before joining the World Resource Institute, Dr. Ajay was working with Center for Science, Technology and Environmental Policies at Hubert Humphrey's School of Public Affairs at the University of Minnesota Twin Cities. Over the years, he worked at various prestigious institutions in India and US, including United States Environmental Protection Agency, North Carolina State University, Indian Institute of Technology, Roorkee, Wildlife Institute of India, and Zoological Survey of India. Ajay holds a PhD degree from Indian Institute of Technology, Roorkee, and has more than 14 years of experience in the areas of infrastructure and environmental footprints, air pollution, and health risk assessment. He has published over 30 international peer-reviewed research articles in international journals, including Nature Climate Change, Environmental Science and Technology, and Atmospheric Science. Please welcome Dr. Ajay Naskure.
Thank you, Dr. Smita, for the introduction. And initially, I was thinking to present on something on the waste burning, but when our previous speakers was talking about this COVID, so I thought that I should change my presentation, and I'm presenting another slide. It's about like impact of coronavirus on the air pollution. So I share my screen. Okay, let me share my screen. So is it visible now? Can you see my can you able to see my screen, Smita?
Screen is there, sir, but still
We
it's
are not able to see
blank.
anything. It is blank.
Now it's coming.
Sir, we are not getting anything.
I think you need to allow me, I guess.
Manvi, can you please take up the issue and try to resolve it?
Yeah, Manvi, you can share the PPT.
Sir has not. Sir is having the PPT. Just make him the presenter, Rahul.
Okay.
Burning is the one of the leading source of PM2.5. Then industries, and then vehicular pollution. This is the pan-India number. These are the pan-India numbers. So when we are seeing this clean India, when we are saying that every place in India is looking clean, there is a clean air. So if this is the truth, then we need to understand these sectors first. For example, if in rural area we are saying there is a clean air, and because of this pandemic, people are staying in their household, but and there is no reduction in this source. And still rural area is showing reduction, it means we are missing something. If there is a improvement in air quality in rural area or area where people burn more biomass, and but that area still showing some kind of improvement, then we need to understand if there is a for example in Uttar Pradesh and Bihar, some regions 90 people are studies are claiming that 90% of the air pollution is coming from this biomass burning from the household cooking fuel. If those areas are also showing improvement, it means our scientists or academician or the researcher are missing something which is very important to understand the air quality. So this is the lesson we can learn from this pandemic. So similarly, when we talk about the air quality improvement in the urban area, because in urban area, the transportation is the one of the leading source of air quality, air pollution. So, and from the last many years, like during pandemic, the transportation has stopped, restaurant is stopped, construction is stopped, everything has stopped. So there is, I think, obviously there would be an improvement in the air quality. But what we can learn as an air pollution scientist or an air environmental scientist, what we can learn from this pandemic, so we can learn the source identification. For example, if some studies claiming that the transportation is contributing about the 90% of the NOx in a particular location or a particular area, if that area is showing only 40% reduction, it means something missing or there is something wrong in our methodology. So this, as an environmental scientist, we can utilize the data available right now. We can collect these data and we can utilize this data for the future research and the policy designing. That is very important thing which we can learn from here. So that's one thing. Moving on to the, I think these are the map. So this is the map is taken by the NASA. So air quality map. These are the NOx air quality map for the. I think this is January 1st January 24 January to 24th March 2019. This is the same time for 25th March to April and January 1st January to 24th March 2020. So I think these are the two old maps, and these are the, I think, this pandemic map. So you can see there is a reduction, but these are the places where we can see that the air quality is not improved that much. So, but these areas are not getting that much attention because there are some other aspects of related to those areas, because there are some power plants and some, you know, this Singrauli area where the lot of coal minings and power plants are there. So what lesson we can learn from this pandemic? Because you know that we need electricity, we need coal, and we need other things. We have to make a sustainable. I think we have to work on a sustainable way to mitigate the air pollution. So I think from this now we can see that these are the some area where we see that lot of reduction in the, like in Delhi, there is a lot of reduction in NOx, means the transportation is contributing something very high amount of air pollution. But this area, there are some other sources that we need to work in a sustainable way to protect the people's life, health. So these type of lesson we can learn from this pandemic. So we, as a researchers, we can collect this data and analyze, and we can utilize it for the future sources. If you belong to some particular reason, and if you see there is a reduction in particular activity, whether it is a transportation industry, but there is a but there is a already there is not much improvement in the air quality, then that is a kind of a research. You can take you can use that data and just come up with some kind of argument and say that there is something wrong in the data, or there is something wrong in the research. We need to have some better results on the better data analysis. So these things we can learn from this pandemic. And moving on to the next part, it's very important. I feel that people are generally talking about the positive impact of the air pollution. Oh, air quality has improved, a lot of things. But in India, poor people are suffering more because of the air pollution during this pandemic. Why? So, as per the National Sample Survey Organization, the recent survey, 2018-19, in India, 87% of urban and 48% of the rural population uses as LPG as a primary fuel. And 9% of urban area and 50% of rural India still uses polluting fuel, firewood, crop residue, cow dung, and kerosene as a primary fuel. And one of the important things which most of us are missing is many of these LPG fuel users are using polluting fuel as a secondary fuel because of some economical, behavioral, or any other aspect. So currently I'm working on one paper just analyzing the data, like how many people as a LPG owner, they are using polluting fuel as a secondary fuel. For example, when I was because I belong to a village, so when we were using LPG for some like a roti making or the chai making, but for water heating or some rice cooking, we were using firewood. The same thing is happening in a I think, many part of the rural area, and which is very difficult from the accounting. So this is the data which I'm analyzing right now. So when we talk about the air quality and when we see that who is getting the benefit of this outdoor air pollution improvement, so only the rich people, not the poor people who uses biomass as a polluting fuel. So these are the concentration level of in the household which are using biomass as a cooking fuel. So 800, the maximum concentration 800 microgram per cubic meter. In Uttar Pradesh or in this belt, many of the households are having a indoor air quality level far beyond the WHO and the CPCB guideline. And during this pandemic, these people are exposed to this high level of air pollution. And how? And before the pandemic, the exposure level was less, but now it is more. How? So I conducted an analysis. So I analyzed the data. People are spending how much time people are spending outside of their household and inside of their household with age. So this is the analysis I'm doing, and I'm going to submit this paper as soon as possible. So this is the 24-hour PM 2.5 exposure to different age group of solid fuel users in urban areas. So the blue line is a pre-COVID exposure for the different age, and this line is the is the during the COVID. So you can see that the people are exposed to the 24 hours. People are exposed to the more, I think, high air pollution in the urban areas. So similarly in the rural area. So, and this is the situation of the almost 50% of the Indian population, which are either using the LPG as the biomass fuel as a primary fuel or the secondary fuel. It means this pandemic has improved the air quality of this of the outdoor air quality, and that outdoor air quality is only good for the people who are rich, because outdoor air pollution comes to inside their household, especially in Delhi. But poor people are still suffering for the air pollution, indoor air pollution. So this I stop. Thank you so much. Thank you so much.
Now I request Dr. Smita.
Thank you, Dr. Ajay Nagpure, for providing insights on the other side of the pandemic that we all are facing right now and highlighting the important issue of indoor and outdoor air quality. I now request you all to please keep your mic on mute mode so that we may be able to listen to the speakers. Moving on to our next speaker of the day, I would like to call upon Dr. Lucinda Elizabeth Doyle. Presently, Dr. Lucinda is an assistant professor in the Department of Biochemical Engineering and Biotechnology at the Indian Institute of Technology, Delhi. Her research focuses on microbiology, particularly enriching novel electroactive microorganisms and understanding what influences extracellular electron transfer in nature. She received her BSc in Honours in Biotechnology from Dublin University, Ireland, and her PhD from Nanyang Technological University, Singapore. Her postdoc experience was at the Singapore Center for Environmental Life Sciences Engineering. With all due respect, please welcome Dr. Lucinda. Dr. Doyle, are you there?
Hello, can you hear me?
Yes, please.
Okay. So thank you very much to the organizers for inviting me to speak this afternoon. So I will share my slides and you can let me know if you can see them. Okay.
Yeah, it's visible. If you can put it on the PPT mode.
Okay, great. Okay. So today I will be talking on the topic of electric bacteria. And firstly, I thought I would introduce myself. So I'm originally from Ireland, where I completed my undergraduate studies in biotechnology. And after that, I moved to Singapore, where I pursued both my PhD and postdoc at NTU. And now I'm an assistant professor at IIT Delhi in the Department of Biochemical Engineering and Biotechnology. So my field is electromicrobiology, which you can also refer to as microbial electrochemistry or part of bioelectrochemistry. And this field is very much interested in electroactive microorganisms, which you may or may not have heard of before. So they are known by various different names in the literature and in the media. Informally, we often call them electric bacteria. More formally, electrochemically active, also electrogens, electricogens, exoelectrogens. But all these names refer to the fact that these microbes can produce electricity. And they do this by taking electrons from their food and converting them into an electric current that we can then harness. So just having an issue here with my transition, getting to the next stage of the talk. Okay, so this mode of respiration that I just described these cells can do is very different to how most other forms of life survive. For example, us, at the moment, we are breathing in oxygen, which is acting as a soluble electron acceptor. So by that, I mean the oxygen diffuses inside of our cells. And when it's inside our cells, basically, we're able to transfer electrons from our food. Say we ate something earlier in the day, glucose, and our cellular machinery will strip the electrons from that glucose and eventually give it to an electron acceptor, which is oxygen. But these electroactive microorganisms differ because even though many other bacteria do things similar to what I just described using oxygen, these electroactive microbes often evolved in environments where there was no oxygen and there was no other soluble electron acceptor that could go inside of the cell. And so because of that, they had to, in order to survive, they had to evolve mechanisms to transfer their electrons from the internal cellular environment to the external environment where there would be an electron acceptor, such as this metal oxide that is pictured. It can be something like an iron oxide in nature or a manganese oxide in nature. So the field of electron microbiology is very much interested in studying this interaction between microorganisms and what we can generally term solid conductive materials. Now, in the laboratory, we tend to replace I think, is there someone who needs to mute? I'm getting some feedback. Okay, so in the laboratory, we tend to replace these metal oxides with electrodes because they're easier to work with from our side, and for the bacteria, they serve the same purpose as acting as an electron acceptor. So this whole process I've just described is termed extracellular electron transfer, and we can visualize here how the cells specifically achieve this. So you can have cases where the cell will sit directly on top of the electrode, which is the black bar, which is acting as the electron acceptor, and through its outer membrane, it will actually funnel electrons, and they pass through outer membrane proteins that are able to carry these electrons. You can also have cases where the bacteria will exist at a distance from the electrode or electron acceptor, but it will dispatch these soluble, we call them mediators, which can carry an electron on behalf of the bacterium to the electron acceptor. And then there are also cases where the bacterium will be tethered to the electron acceptor by way of cellular appendages that the bacterium has managed to create itself. So as you can imagine, there has been immense interest in harnessing this bacterial current in the form of bioelectrochemical devices. And a very common one is the microbial fuel cell. And this was originally developed with the vision that it would be able to treat wastewater. At the same time as treating wastewater, it will be able to liberate the trapped electrons stored in the wastewater. And it will also, through doing that, be able to generate power. And this has had many successes, but nonetheless, there's still a lot more work to do because the actual power output from these types of devices is not yet at the level that we believe it could be. And there have been various efforts to experimentally optimize this in terms of design considerations of the devices, but this has not solved the problem entirely, and there are a few reasons for this. So typically, when we think of a research field, there's usually a large amount of fundamental research that happens that then takes a long and meandering course before application-driven research occurs. And when we look instead at this field, while there has been fundamental research carried out, there was so much interest, understandably, in harnessing this current and power that the emphasis really was on application research. And so because of this, there are some missing pieces along the way which are important to fill in order to be able to fully harness this type of technology. So with that in mind, I want to share with you parts of a research project I was involved in that tried to fill in some of these blanks. The aim of our project was to try to grow new electric bacteria. So to provide some of the background context for this, at the beginning of the study, we had noticed that whenever research groups tried to grow new electric bacteria, they often ended up isolating Shigella and Geobacter, two specific types of electric bacteria, over and over again. And we identified two reasons for this that may be to blame. So the first was that, understandably, because people are interested in applying MFC, microbial fuel cell technology, the enrichment device in these studies, so when we're trying to enrich or grow these bacteria, was often an MFC. At the same time, we identified that many of these papers had in common that their inoculum or starting material was wastewater. So whatever bacteria you were going to isolate originally came from wastewater. So from an applied perspective, this makes great sense, but from an ecological perspective, taking this approach of just this one device style and just this one inoculum material, you may actually be missing out on other electric bacteria. So we opted to go for a different approach. We switched from, instead of using microbial fuel cell, we used a 3-electrode setup, which is borrowed from conventional electrochemistry. And it basically has the advantage that you can very closely control the electrochemical environment of your enrichment or your growth conditions. And we also chose, instead of wastewater, tropical climate sediment from Singapore. And this was chosen because this tropical climate sediment is very much underrepresented in this literature. It hosts a very large diversity of microorganisms, some of which may be electroactive in nature. So broadly, the questions we were asking were, could we enrich novel electric bacteria? And really, how widespread is this capacity for extracellular electron transfer in nature? So we found that we could enrich a mixed species community that was electroactive, and we could establish this by monitoring the current output with time across multiple enrichment cycles. 6 cycles are pictured here. And the key point is that using this electrochemical technique called chronoamperometry, measuring current with time, we could see that the current could be maintained over a long period of time. So we knew we did have something electroactive. And we were interested to see who those community members were that were alive in this enrichment. So we sequenced the biofilm that was living on the electrode, and we found that it was heavily abundant in Geobacter, which, like many groups before us, was what we were growing in large amounts at the end of the day. But this was a species of Geobacter that we had not expected to find in this study because of the electron donor, or food, in other words, that we were using. So even though it was a familiar name, we definitely wanted to sequence this isolate, or isolate this strain, because it was clearly unusual compared to other members of its species. So we did isolations and sequenced the isolations, and to our surprise, we found that what we had isolated did not belong to Geobacter. We had instead targeted an Aeromonas strain and an Enterobacter strain, which, as you'll see in the last image, they did not feature in this list of the most abundant genera. They would have been squarely in the other category. So we were really intrigued as to how these bacteria had survived in such electrochemically active conditions. So we wanted to establish if the isolates were capable of extracellular electron transfer, and using a similar technique, this time measuring the total charge passed over a 2-week period by the bacteria, we established that these strains were electroactive. And this had significance for us because we termed these isolates a case of non-traditional electric bacteria, or weak electric bacteria. And it was important for us that they had managed to survive across multiple enrichment cycles on electrodes that had been dominated by the highly successful Geobacter. So for us, this indicated that this has a clear survival advantage for even non-traditional electric bacteria to be able to perform extracellular electron transfer. So even if they're not particularly good or efficient at it, it still gives them an advantage to be able to carry it out. They couldn't get to great abundance in this environment, but they could still hang in there on the electrode and survive. And then more broadly, this fed into a wider picture that was emerging in the field, whereby there is an actual spectrum of electroactivity. So while many studies have focused on their findings of the strong electricitants, there's also this middle ground where perhaps the microorganism is slipping between this style of respiration and another more common style. And then, of course, at the opposite end of the spectrum, there's the case where you have non-electricitants, so things that cannot create electricity in this manner. And they would die under these types of enrichment conditions. And since then, it's been found that even microorganisms associated with humans may be weak electricitants, such as the human commensal Enterococcus faecalis, which often can be found in the human gastrointestinal tract, has been found to be capable of extracellular electron transfer. So in terms of what all this means, it highlights that there is a continued need to investigate unexplored natural environments to find novel electric bacteria. By finding new electric bacteria, we may also discover new mechanisms by which they carry out extracellular electron transfer. And altogether, this fundamental understanding of how extracellular electron transfer occurs and what drives it and how we can drive it in the laboratory, this can all benefit the bioelectrochemical devices, enabling us to actually harness this great sustainable technology and way of harnessing energy in remote devices, powering remote sensors, treating wastewater in rural environments, using these types of microbial fuel cell technology. So with that, I will end my talk, and thank you very much for your kind attention, and I hope that this was helpful. Thank you.
Thank you, Dr. Lucinda, for talking about my area of interest and research, that is the anode respining bacteria, electromicrobiology, and microbial fuel cells. I think following your talk, some of our participating students would be interested to work on the same. Thanks again.
Great.
Now
Thank you.
advancing towards the next speaker, Ms. Shubhi Dupar. Ms. Shubhi Dupar is an IYCN board member and leads the URI North India and Afghanistan. She is a community builder. Shubhi Dupar is a peace educator, trainer, and spokesperson with experience in promoting interfaith consensus and social inclusion among people of diverse cultures at local and global levels. She has attended South Asian University and Lady Sri Ram College both in Delhi. Her mentorship includes guiding grassroots workers on resource mapping, resource building, communications, and experiential learning. She has coordinated the relief work of more than 7,000 persons across India during COVID. We are very happy to have you with us, ma'am.
Thank you so much, dear, for such a generous introduction. Although I'm not from the science background, and this makes me really nervous at this point in time. But my hope and my feeling is that while science and metaphysics observe and analyze different aspects of the same truth, it is metaphysics which offers access to the truth in its wholeness. And with this very thought, I hope that we're able to intertwine the importance of faith-based work, and as I would like to call it on this call as Reengineering Science. Why faith-based organizations? In specifically in conferences which talk about science. So to begin with some of the answers, the Secretary General of the UN, late as recent to 3 weeks ago, made an announcement that to resolve the COVID-19 pandemic and environmental emergencies, we must work together as an international community. Like the coronavirus, environmental crisis respect no boundaries. Isolation is a trap, and we should all be working together now and together. So, hence, I hope, and for the standardized understanding for everybody who is looking at why faith-based organization and is probably thinking of religion and spirituality and different faith leaders in this mind, I would like to simply use this definition by James, who says that a religious congregation with primary mission of worship and religious education that offers different kinds of theology, structure, size, location, or types of teaching is a faith-based organization. It's an umbrella term for the purpose of this presentation. And while I talk about faith, we are coming from an interfaith perspective and not supporting one or the other. Where does URI or my organization stand in all of this? We are a global grassroots organization in 109 countries with 23 regional offices around the world. And I manage one of them in India, which is the north of India. We have a consultative status at ECOSOC and have also been recognized by United Nations Alliance of Civilizations as one of the 10 most innovative and successful grassroots initiatives. My organization looks at engaging different people from different religious backgrounds to address a social problem. And a social problem can be across any of the SDG areas that we are all aware of, but we work specifically around 14 action areas that are quite similar to the UN SDGs. These action areas also include environmental crisis as one of our primary focus areas. So environmental crisis and faith. We've all, in some way or another, following any strand of religion, faith, or spirituality, have one or the other time experienced these decades of oversight and neglect. For a lot of time, religious institutions, as many of us on this call would have noticed, has contributed to large sums of plastic waste, which roughly is around India generates around close to 26,000 tons of plastic a day, and I'm sure there are many more other statistics to support. of the amount of waste that's been created. However, it's not just the plastic waste. Faith-based institutions are also seen in the space of using water, producing waste, energy efficiency, protection of animals, sacred forest areas that they have access to, which communities or indigenous communities also protect and use accordingly. It's just business as usual. It's in a regular part of our lives and we see it, but we never, as I say, re-engineer science to see where faith and religion is playing a part. Alternatively, we also see from the supply chain perspective, um, we never imagine the agarbatti or maybe camphor that is offered generally in temples not being wrapped up in plastics. Or we can't imagine religious institutions not being lit very brightly during festival times. We can't imagine a place of worship to have no electricity. So, energy consumption comes in that space. Um, so here is where the larger problem is, where we have to see where the two worlds are intersecting, and so where does science has to fit into all of these things? As I mentioned in the previous slide, there are some of the broad areas that faith-based organizations can be looked at and are a major contributor to the problem. Unfortunately, the assumption is that no data means no problem. Whereas if we have to see, there are very, very extremely limited studies that kind of specifically highlight the contribution that faith-based organizations make while intersecting with environment. So if we have to reshift or reframe our lenses, then we need to look at how we can understand sustainable development and the concept of sustainability in faith-based organizations, in FBOs. It's also important, as I mentioned, to develop a scientific hindsight at the first place. Indigenous communities, because of the importance of forest, preserve it because they have a certain attachment to it, not just from the importance of the place, but also from a very faith perspective. We need to employ environmental designs and solutions which have been so brilliantly been presented since morning to cater to issues and research areas on food, health, nature services, water, solar panel, energy efficiency, um, waste production, segregation, recycling, so on and so forth. Uh, Science and faith can also be a promoter of a scientific, culture-based ambassador, wherein both can come together, which means COVID-19 in itself, where faith institutions were either preventing the problem or were kind of disseminating information correct and partially incorrect as well. So we very, very poignant examples in times of COVID, where faith-based organizations were playing this massive role. There are many people on this call, I imagine, would be seeing these two words as very, very different ends of the spectrum. But in my perspective, if we have to address a larger problem in the environment today, it's time that we come together for a better tomorrow. As I mentioned, some of the sectors that faith-based institutions can engage and need your help is in water, wastewater treatment, waste, biogas for ashrams and other residential locations, renewable energy, energy supply, sustainable housing, um, for larger institutions that we might all be associated or the entire uh, functioning of the whole overhauling of the system. So there are many retreat centers, there are many places of institutions of reverence, of prayer that we might not be going to. But each of these complex systems or geographical areas, are definitely engaging on these basics of water wastage, renewable energy, sustainable housing in some way or the other. You can only imagine an ashram complex where all of these things come together, and there's just shouting out loud for more sustained, informed, and effective channeled guidelines from the science community, as I would like to call it. Why FBOs? I mean, there is so much of problems that I've already identified. We've identified what are the spaces where one could look at for engagements. I've also been talking about coming together of collaborations of seeking synergies. But what is on the other end? What are faith-based organizations that they can offer to this amazing, brilliant community? So many of us, this is I'm sharing some of the pictures from some of the common faith institutions, and this is just only for reference. They have massive followings. They are also major behavioral change influencers. They're also people who very clearly advocate about a simple, sustainable lifestyle. So it also helps in some ways or another to bring about lifestyle changes, which we all are presently talking about in COVID. There are also those people, as I mentioned, we've all come across examples where faith institutions during COVID have come together um, to bring the science behind COVID and spiritual practices. And we've seen it, during several festivals that went in the past month of April. They are potential multipliers, which means that with probably one of the faith leaders, you'd be averagely be able to reach maybe millions of their followers. And fortunately, unfortunately, while the government plays a very, very crucial role, the faith leaders are somebody who holds a very trustworthy positions for all stakeholders, local people, um, and specifically the larger community. They are drivers of cultural values, social inclusion, political engagement, and economic prosperity. And they hold a certain, trust and the stage amongst the local and national and international communities. So, hence, if we are able to bring knowledge systems in a way that we can incorporate into their existing systems, then we might be able to marry the two ends of the spectrums that we are looking at this point in time. Some of the faith-based organizations that you might already be aware of, and there are many more, are practicing the kind of sustainable, effective, scientific methods that we've all been talking through since morning. And some of the examples are from the Muni Seva Ashram in Gujarat, makes its premises entirely green by using solar, wind, and biogas energy. In Tirupati, which is a very, very famous known temple, the solar operated community kitchen helps in the shrine to save at least 20 lakhs every year by reducing carbon dioxide emissions by 1.2 tons. Help Us Green is a civil society organization, and there are many more, which produces a range of products from flowers, incense sticks, bathing soaps, just by collecting the waste that they get from these religious institutions. Sai Baba Ashram, Art of Living, Parmarth Niketan, Golden Temple are some of the very common examples that we've heard of. But they also have these initiatives of recycling solid waste, of using biodigester toilets, of creating specific canals and ponds to recharge groundwater, um, for treating wastewater, um, you know, and construct wetlands, and also using wind and solar power to sustain their entire ashrams. So these are some of the examples, and there are many, many such more examples that are out there where institutions have been trying and are already embarked on this road of sustainability. However, there is much more to do, and it is also one of my requests to the brilliant community to join hands and see what we can seek in the future. To say, do we have actually policy safeguards to support the kind of interventions that we're thinking of? Can we actually bring the science and spiritual worlds together? The answer is yes. In at local, regional, state, national, and at many levels, including some of the recent examples of the Plastic Waste or the Solid Waste Management Act, which clearly specified that even faith-based organizations are to be governed by waste management rules. Excuse me. Alternatively, also there were clear guidelines and rules about people who were serving to more than 100 people had to be managing their safe disposal. Also, recommendations to have a recycling and a compost pit within their own campuses. So these are some of the guidelines which the government of India actually does provide and does cover to look into these institutions. However, there is of course a much larger need that we need to incorporate our different parts. So what is the way forward? We've looked at what the problems are very.
Sorry for interrupting, Ms. Subi. Please, could you summarize in 1 minute?
Sure. So what is the way forward? So for us, I think I've spoken largely in terms of what the problem is, what can be done, what are some of the broad specific issue areas. Some of the thoughts and suggestions would be to actually be looking at equipping faith-based organizations with scientific tools and academic resources for for change in the way they look at things, and also nurture this bond between religion and environmental sector. It's also a request to be undertaking academic surveys to identify knowledge gaps and lack of data, recognizing best practices of the field and supporting them to improve their efficiencies, and definitely organizing many more convening and training platforms such as these to bridge the existing gaps between communities. And lastly but not the least, education and sensitization through platforms like Vinha and UPA could be utilized for reaching out to peers. I'd just like to quickly thank all the university partners, UNAP India, Greenfield, Bhumi, who've been very instrumental in combining these two worlds, and I look forward to seeing more synergy. Thank you so much for giving me this space and opportunity.
Thanks a lot, Ms. Subi, for speaking on an entirely different topic and connecting science and faith. Science can definitely build a community which can understand science for the elevation of the society. Now let's call upon the last esteemed speaker of the day, Shri Rishabh Khanna. Rishabh Khanna is the Chief Impact Officer at Earth Bank and co-founder of Enviro Health Matters. He is driven by his calling to strike a balance between social and ecological systems. For over 10 years, he has focused on applying new economic and business models in accordance with the planet and all its creatures. He founded the Indian Youth Climate Network. He has worked with organizations like Initiatives of Change, WWF, Climate Action Network, UNFCCC, UN Habitat, Ministry of Defense in Sweden, Ministry of New Renewable Energy in India, Ministry of Environment and Forests, Tata Group, and the PwC, and more. Over to you, sir.
Thank you for this great opportunity. I'm just wondering, should I share the screen, Pinaki, or will you do it?
Yes, sir. Please share your screen, sir.
Okay. Can everyone see this slide?
Not yet, sir.
You can't see the slide? the- okay. Can you see my screen now?
No, sir.
Okay. Um, I sent my now.
Visible now, sir.
Yeah, it's visible. Yeah.
All right. Okay, so thanks very much for that beautiful introduction, and thanks to all the previous speakers. It's been a great experience to listen to some really interesting thoughts, both with what's happening with COVID, what we can do in terms of connecting science and religion, the latest technology in wastewater treatment. So very, very enlightening. Um, I think today what my sharing is mainly going to be about. For me, science is all about measurement, and if we can measure things, we can change things. And one of the most important things is money. So what is so funny is that all of us are now worried about COVID and all the health impacts and of course the economic impacts. But the interesting thing is that we need to change the way money works. We need to change the way decisions are made about how we share our money and how we save our money, how we invest our money. So what we are doing in Earth Bank is essentially creating a green digital banking platform. And today I'm going to specifically talk about what we are doing in terms of measuring and carbon credits and using actually satellite data for monitoring, reporting, and verification, which is very difficult normally because you need to spend a lot of physical time to do that. So, the solution we're providing is a one-stop shop, wherein, as you know, in climate change, with the major issue is how do we sequester carbon, and trees and forests and land is one of the biggest source. But if we cannot measure the amount of carbon that's being sequestered, you cannot pay people for the carbon that they are sequestering. So that's the focus, and we think that if by measuring ecosystem services like carbon sinks, you can move from a degenerative economic model to a regenerative economic model, which is saying that let's invest more money into things that actually retain water, reduce soil erosion, reduce the impact of extreme weather events and things like that. So, I mean, at the bottom of everything, India is still an emerging country. We're an agriculture country. You see that this is a poor farmer. We still have, issues of farmer suicide. We saw what happened to migrant workers also in this time of COVID. And so the challenge often has been in terms of carbon markets that these poor farmers are often neglected. So most carbon credits go to people who own like thousands and thousands of hectares of land. And unfortunately, most Indian farmers or most poor farmers in the world own less than 2 acres of land. So, and it's a very long process to do a feasibility check, to do all the audits, to actually make sure that, the person who is monitoring your land can measure it. So we have reduced that process to like 3 simple steps. Right now you can't see it, but I mean, essentially what we think that through satellite data, through high spectral satellite data, we can measure as low as a few acres of land, even few hundred square meters of land. And so once we have uploaded, the farmer has uploaded their title deed, and we can see, okay, this land is owned by them and they are taking care of it. We can monitor and verify the amount of carbon they are sinking. They automatically get paid for the amount of carbon they are sequestering, either through organic farming or through planting trees and taking care of trees. So how does the flow of funds work? Today, we have a way in which there are subscribers who would subscribe to the Earth Bank Plus accounts. That money would go to, we are working right now with an organization in the Sundarbans, which will, these people would, they own land and they look after these trees. Since we have their satellite coordinates, we can monitor and verify every 5 days. We can get data on the trees are still standing and the carbon is still being sequestered, and so they get finally paid for the carbon they are sequestered. So that's the key, value proposition. So this, some of this data is from Australia, and I was told that this conference, this webinar is also to look at things that we need to improve upon. So one of the things that in India we don't have yet is a soil carbon standard. Like in Australia, they have a soil carbon standard, they have a soil carbon market. So it's much easier for us to get farmers in Australia, for example, to get paid for the carbon they're sequestering. And what we are doing here, as I said, is like initially, because the cost of verification is so high, so only landowners which had 2,000 hectares could, get paid for the carbon they're sequestering. But now we're bringing that down to 250 square meters. And also the error bars, as you see, like the traditional methods of monitoring and verification, there was in 2017 much bigger difference between the accuracy of the traditional methods and satellite remote sensing. But as you see now in 2019, the difference is very less. So the accuracy of remote sensing has improved much more. And we can even see that, a lot of satellite data recently, when there was a cyclone, now the super cyclone, that like that data on extreme weather events was, we were able to give to communities, up to a week before the extreme weather event. And that's improving also, our ability to mobilize in case of, disasters. But also with something very, specific like this, in terms of measuring soil carbon, we can become more and more accurate. We have done a lot of ground data collection, both in the Sundarbans and in Myanmar. This is again just about, how the account works when subscribers, subscribe to the account. Then part of the money goes for planting trees. We are currently focusing a lot in Australia. As I said, Australia already has a soil carbon standard, and it's easier to get paid for that in the market. In India, we have a mandate to plant 10 million mangrove trees in Sundarbans. As you know, mangrove trees sequester 100 times more carbon than the Amazon forests. So it's a huge, sponge for carbon, but also mangroves are key when it comes to, protecting vulnerable communities from extreme weather events. So yeah, in the next 1 year, our focus is to reduce the error bars from 15% to between 1 to 5% between satellite remote sensing and physical verification traditional methods. Is to make sure these 10 million trees are planted, and the people who are planted them get paid not only for planting the trees but also for the carbon they are sequestering, and that will help us to create very good data sets and automate. So one of the things in this technology is also about machine learning. So once we are able to show that there is a certain amount of carbon being sequestered with certain image files from satellite data, we can automate that. And so it will like become faster and faster to be able to do that. And initially it will be about wetlands and mangrove ecosystems, but then we will go into soil carbon. I mean, this is some of the Sentinel-2 data. So we have access to the data from the European Space Agency, and that is the data we are going to use for also measuring soil carbon. Um, we are accelerated by something called the Nordic Climate Kick, which is a climate accelerator in the EU. We are supported by the Jane Goodall Institute. We are also helping the ecosystem restoration camps in helping, raise donations for setting up these ecosystem restoration camps. So of course the platform can do a lot more. We can help with both with transfer of money, saving of money, investing the money, but the main thing is like we can like measure the impact of how you're investing your money. So this is the team. Tom's the CEO, and Chow is the COO. She has got a lot of experience with banking. uh, Pedro is the chief data scientist, who's working with Imperial College, and Franco's developing the blockchain algorithms for the actual backend software. So yeah, well, that's it. So I would just say that money can be a force for change, and I think we need to measure how we are saving and investing our money. And if we can save and invest in the right way, hopefully we can redefine and reshape an economic system which does not create such pandemics like the COVID. And please go on to the website if you want to know more. We are launching a crowdfunding campaign later this summer, and so you can sign up and get to know more information.
Thanks a lot, Rishabh, for enlightening us with your valuable talk. And listening to the esteemed speakers of both the sessions, now before inviting worthy Registrar Dr. Sunil Kumar Garg for the vote of thanks, I would like to invite Professor Vivek Kumar for the reflections of the webinar in a few words and formally announcing the closure of the event. Vivek sir, please.
So again, I would like to congratulate your team. It's a great effort, and the whole, if we talk of the two sessions we had today, we had very diverse speakers, but at the same time, all of them were talking about, of course, they were from different sectors and different arenas, but all of them were actually talking about in one direction. So if I just summarize from the discussion we had today, we got to know about how industries or many other sectors are not working in isolation, but actually and not insulated for the concern of the society and environment in particular. But all these sectors, including industry, they are progressing in a direction which reflects the desire of the society. And all of them are responding, whether we talk about regulatory bodies, whether we talk about research council, enterprise organizations, in fact, the organizations working for sustainability, all of them actually are responding to the society's call, especially when there is a concern for the better environment. So what I understand from today's discussion, that perhaps the solution is that concern for environment should be in our way of life. And if as a consumer for services and goods, if we also understand the cause and effect relationship pertaining to the pollution of the environment, we will find effective solution and preventive measures, not only for industrial products or industrial processes, but also in other spheres of life too. Of course, there is a need for innovation, but this innovation, as today's speakers highlighted, that the direction of this innovation should be sustainability and conservation, environmental conservation. In fact, I was highlighting this in some webinar a few days back, In India, we actually like a lot of, we come to the sustainability analysis of the technology. We are actually lacking in in the direction. Point which Dr. Nagpure highlighted again is that we are neglecting one area. Of course, there are several areas we are working, but we have to work in comprehensive manner, and no area should be neglected. And our direction should be the sustainability or achievement of the sustainable development goals. Right. So I believe that we all should work for creating awareness about the various aspects of ecosystem services. We also should work in the direction to understand biophysical limits of the growth. Many speakers highlighted that. And finally, I believe that such discussions like the seminar we had today would help people working in different sectors and arenas in coming at one platform, knowing each other, knowing the concerns of different sectors, the progress of the different sectors. And I'm sure that with these efforts, we will come together and work hard for rejuvenating our environment. Thank you. Thank you, Smita.
Thank you, sir, for reflecting and summing up the whole discussion of the event. Now, I would like to take the privilege to introduce our worthy registrar, JC Bose University of Science and Technology, YMCA, Dr. Sunil Kumar Garg. Dr. Garg did his postdoctorate in thermodynamics from Indian Institute of Technology, Delhi. He has a vast experience in academia, research and development, industries and administration, spread over about 3 decades. He has about 24 research publications to his credit in national and international journals and has attended 23 national and international conferences. His area of research interest includes thermodynamic properties of industrially important liquids and their mixtures. He has served many academic and technical institutions and is a member of several academic organizations. I now request Dr. Sunil Garg to give the vote of thanks. Over to you, sir.
I am audible.
Yes, sir.
Okay. Good evening, everyone. Hello.
Yes, sir. You are audible, sir. Yes, sir.
We can hear you, sir.
Okay. Good evening, everyone. Professor Dinesh Kumarji, Professor Ranjana Agarwal, Director CISR and President of Vigyan Bharati, Vivek Kumar, National Co-Coordinator, Unnat Bharat Abhiyan of various organizations, officials from the partner organization in the program, faculty members and participants. It's a privilege to propose vote of thanks in today's webinar on science and engineering for nature conservation on World Environment Day, organized by Environmental Science, JC Bose University, in association with Vigyan Bharati, Unnat Bharat Abhiyan, SOCAM GEM, CP Private Limited. Extremely grateful to the Honorable Vice Chancellor, sir, for being with us on this occasion and providing all to make this webinar success. Sir, your gracious presence is a source of great motivation to all of us. Really thankful to Professor Ranjana Agarwal, Director CSIR, NISTAD, and President of Vigyan Bharati. Gracious presence and word of encouragement. Support in event on relevant topic in this difficult time of pandemic. Special thanks are to Professor Vivek Kumar, co-convener Unnat Bharat Abhiyan, for providing guiding and supporting in organizing this event program. I would also like to thank our distinguished speaker of the second session on sustainable development engineering for making this session interesting and meaningful for all of us. Special thanks to our partners of this program, Vigyan Bharati, Unnat Bharat Abhiyan, SOKMG, and CP Consulting Private Limited for providing their valuable support. I would also like to congratulate and thanks the team of Environmental Science Department of JC Bose University of Science and Technology, led by Chairperson Dr. Renuka Gupta and coordinated by Smita and Pinata for nicely and successfully organizing this webinar. In the end, I thank all the participants for attending this program. Once again, thank you very much to all of you to be part of this program. Thank you very much.
Thanks a lot for your kind words, sir. Now I think Pinaki wants to share a few words. Pinaki, over to you, please.
Thank you, Smita ma'am. We are drawn to the closing of this webinar. But before that, I will just take a couple of minutes to share that this webinar wouldn't have been possible without the blessings of our chief patron, Sir Professor Dinesh Kumar Ji, Honorable Vice Chancellor of JC Bose University of Science and Technology, with patron support from our worthy University Registrar, Dr. Sunil Kumar Garg Ji. Thank you, both of you, for being such an encouragement throughout the day, and your presence is highly appreciated, and it's an honor for us to have you. We had with us our senior advisor, Professor V.K. Vijay Ji, who is the National Coordinator UBA and also a professor of in CRDT in IIT Delhi, along with Professor Ranjana Ma'am Ji, the Director of CSIR NISTETS and President Vibha Haryana. We had the privilege of having us my mentor and guide, Professor Vivek Kumar Ji, who is the National Co-Coordinator of Unnat Bharat Abhiyan and Professor in Center for Rural Development and Technology, Indian Institute of Technology, Delhi. Thank you, sir, for being with us and for entire day and for extending and enriching closing remark for all the sessions. We value your comments. I want to personally thank Dr. Renuka Gupta, who is the chairperson and HOD, Department of Environmental Sciences, JC Bose University of Science and Technology, YMCA, Faridabad, for being a kind of backbone to our team and giving us an able direction support. Thank you, ma'am, for your contribution. It's really appreciated. I would conclude here by introducing the organizing team consisting of my able colleague, senior guide, organizing secretary and lead coordinator, Dr. Smita. I remember when we had planned this seminar, webinar 10 days back, we were just thinking that how would this be received. And I'm so proud to have in my team the core organizing committee with all the faculties from the Department of Environmental Sciences, Dr. Somveer Bajar ji, Dr. Navish Kataria ji, Mrs. Anita Girdhar ji, Mrs. Monica Mago ji. They have been working 24 hours a day non-stop for the last 10 days without even thinking of their own health. My special thanks are reserved for two people from the UBA, Manvi Ajit Singh and Rahul Chaudhary. They are the ones who have been managing all the registrations online and offline and including this platform wholeheartedly without even thinking of their own health. We know that what's going on in our team with the health part, but thank you to two of you for making this possible, and also to the participants, whether you are on YouTube, whether on this WebEx platform. We feel really honored to have your presence. We are so glad that you could make up on this day where more than 1700 events are registered globally, and this is the only event in India which is discussing about science and engineering role, the role of scientific community for nature conservation. So congratulations to all of you. This webinar.
I now call upon Manvi for the concluding remarks. Manvi, please.
Thank you so much, Dr. Smita. Respected dignitaries, all the participants who are live with us via WebEx and YouTube, and all our beloved organizing team. I would like to take this opportunity to thank you all, as without your support, this event wouldn't be a great success. Participants will be getting their certificate via email through feedback form filling procedure. And without wasting any time, I just announced the closing of the webinar. Thank you so much.
Thank you, Samita. Thank you, Pinaki.
Thanks a lot, ma'am. Thanks a lot.
Ma'am.
Thanks a lot to everybody.
Thank you all.
Thank you, Dr. Vivek.
Thank you, everyone.
Thank you, Rishabh. Thank you, Shivi. Ma'am. Thank you, ma'am.